Welcome to Python Data Analysis Portfolio Full Project. And this project is beginners to advanced. So if you finish this project, I guarantee you, you've covered 90% of the tasks we do in data analysis with Python. This project demonstrates the complete data analysis process using Python. Now, by the end of the project, you will learn. I'm going to import the required library. First of all, we'll be importing Pandas. Then the second library is NumPy. So we're going to import Matplotlib, then the next one, Seaborn. For our statistical analysis, I'm going to import from SciPy. I'm going to import stats. Then I will run. Good. For how to load data sets, the easiest way to load data sets is to go back to the file that you created. This is where my project is, Python Data Analysis. So this is the project. I'm going to load the data sets from the local PC into this file on the Jupyter notebook. So how do I do that? I'll click on load, show all files. So I'll go to where it is located. So this is it. So I've loaded it into my Jupyter notebook, but it is inside the file that I created. So where I saved the project that I'm doing. So what I will now do is I'll copy this. So this method will help you not to start copying the path from the local PC where you saved it. You just copy it from here. Go back to this. So we are going to name our data set sales. Sales equal to so I'll just paste it and run. Good. So now I've imported this data set, and the name of the data set is sales. So now let's check, inspect, and explore, and also understand the data set. Now we want to inspect this data set. And how do we do that? We use all these functions. We carry out all of this. First of all, we are going to check the head. And how do you check the head? Sales dot head. So sales.head will give us the first 5 head of the data set. Now we have this, and this is our data set. The next thing is for us to check the tail of the data set. So we want to check the last 5 rows. Sales.tail. I'll run it. So this is the last 5 rows that we have. Then the next thing we are going to do is sample. So we're going to use sales.sample. Good. So now, so this is the sample of our data. So this is what we have. Now let's check the shape of the data set. Sales.shape. All right, so from here we have 1005 rows and 22 columns. So this is the shape of our data set. Our data set is 22 columns and 1005 rows. All right, so the next task is for us to display the column names of these data sets that we just imported. Now I'm going to write sales dot columns. So once I run it, I will have all the column names. So this will help us to check the spelling if there is any error in the column names. So this will help us to see all the column names that we have in the data set. Then the next task is we want to check the data types of all the columns in this data set. So we write sales dot the types. Now it will give us all the data types. So these are different data types that we have. Then the next task is for us to check the summary statistics of the data set. So for us to check the summary statistics, we use dot describe function. Okay, so I'm going to write sales dot describe. Now, this is the summary statistics of the data sets. Here we have 1005 rows, so this is complete, and we have a missing value here. We also have a missing value here, but these ones are complete. We have the mean. So mean quantity, this is the average, mean is average. So we have all the average in each of these columns. Then the next one is the minimum value. So for example, the minimum age is 18. The minimum quantity is -3. So the next one is 25th percentile, 50th percentile, 75th percentile, and the maximum value. So this will give you the summary statistics of what you have in your data. Okay, so the next task is for us to get the information about our data set. So we use sales.info to do that. Good. So this has given us the information. We have a total number of 22 columns. The row is from index 0 to 104, and the column is 22. But because the index is always starting from 0, so we have 0 to 21. So this is the information about our data set. And we don't have any empty row. We don't have any empty row, but we have missing values. So if you look, anyone that is not up to 1005 rows, anyone that the count is not up to 1005, it means that we have a missing value there. Okay, good. Then the next thing we are going to learn is how to clean data, how to check for missing values and duplicate values. So we're going to learn how to clean data, how to check for missing values, and how to check for duplicate values. Now, for us to check for missing values in this data, we use sales.is null. So if you run sales.is null, it will give us the output in Boolean form. So meaning false, there is no null value here. There's no null value. Anywhere you see false, there is no null value. But since the data set is too plenty, we can't see everything. We add dot sum. So meaning, so now it has summarized everything for us. Under customer name, we have one missing value. Under gender, we have one missing value. City, so all these places we have missing values. But anyway you see 0, it means that it is complete. We don't have any missing value. And mind you, and even if you see dots is NA and dot is null, they are the same thing. So let's check it out. So I'm going to write sales dot is NA dot sum. Let's just see everything that we're good. So it's going to give us the same result. So meaning you can use is NA, you can also use is null. All of them will give us the same result. Now we want to check duplicate record. So for us to check if we have any duplicate record in this, we use dot duplicated. Okay. So we have up to 5 duplicates. So if I want to check, if I want to display those records, so I'm just going to copy, attach the name of, okay. So this is duplicated. So now, so these are the duplicate record, meaning this is the duplicate, this is a duplicate, another duplicate. So we have 1, 2, 3, 4, 5. So this is how to display your duplicate record. Good. Then the next thing we are going to look at is data type conversion, how to convert data from one data type to another. So let's go back and check what we have. So from here we have objects, ID, customer ID, all these things, they are objects, gender objects. We're going to drop all these duplicates. All right, so let's go back and check. So now we've dropped all these duplicates. We no longer have a duplicate value here. Okay. Now the next thing we are going to do is what? We're going to drop all the rows where we have empty record. So we use sales dot drop NA. All right. So for us to see if we actually dropped all the empty records, I'll run sales dot tail. So we now have about 999 record. Let's check sales dot is null. Okay. All right, so we still have this value because I've not assigned it a name. So I've not saved this. So what I'm going to do now is sales equal to this. Okay, sales equal to sales. So if I come back here and check, so we have 0000. You no longer have empty records. So now it's not all about dropping NAs. Even if you drop NA, you must create a new data set out of it. Because if you did not assign sales equal to sales job any, it will still be running, it will still be giving you the original data that you have. But since you've already dropped the NAs, the null values, you can now attach it sales. Is either you give it new sales or sales equal to this. But since we don't want to use the data set with empty record, I'm going to assign it sales, the sales again, so that sales will no longer have empty cells. It will now be the normal sales without empty record, so that whenever we put sales, we are calling this. Good. So now the next thing we are going to do is data type conversion. We are going to convert data from one type to another. For example, if we go back to the information that we have about the data, this is order date, and order date is object. Order date is not supposed to be an object. It is supposed to be a date time data type instead of an object. So now we are going to convert it from object to date time. Why do we convert it? So that it will help us to, in date calculation, anytime we want to calculate anything that has to do with dates, Pandas or Python will recognize the data type as a date instead of an object. Leaving it as an object, Python will recognize it as a text or an object. But if you convert it to date time, Python will recognize it as a date. Let's check the data type of order date. For us to convert order date from object to date type, so we have order date equal to, we use a function called to date time. Date time. Good. So now let me run sales again. Sales. I wanted to observe something. When it was in object data type, it was in this format, but now I've converted it. It is now in date time format. Now let's check info again. Sales.info. So order date is now in date time. Good. Now the next thing we are going to be looking at is feature engineering. What is feature engineering? Feature engineering is just the process of creating new variables or features from existing data to make the data set more useful for data analysis, visualization, or machine learning. Now, feature engineering is, you're just trying to create extra columns from the original data set that you have. You have your data set, but because you have analysis that will require more columns, if you want to achieve something, you might be needing, or you will be needing a particular column for that. But that data set that you have originally doesn't contain that column. So the process of you creating that new column, what you're doing is feature engineering. So in this project, we'll be looking at revenue, that's creating a new column called revenue. That's features like revenue, total cost, profit, profit margin, month name, and quarter, year, and day name. So we'll be creating extra features, extra column from the original data set that we have. That is feature engineering. Now let's go and do that. Now we want to create a new column called revenue. Total revenue. All right, so let's see the head of our sales. Sales.head. I just want to see three. I want to create a calculated column called revenue. And revenue is quantity by unit price. That's the total revenue. So I'll bring out the column, the quantity column. I'll just come here and copy it to avoid error. So I'll copy it. Now, if you copy, please remove the white space to avoid error again before you get another error where you're trying to avoid error. So by unit price. So I'll copy again. Now I'll run it. Good. So this is the extra column that we created. Now I'm going to give it the revenue name. Revenue. That's revenue equal to this. So, but I want, so this is going to be a colon, not just revenue. So, and the colon is inside sales data set. So I will insert it inside the cell, inside the data set and run. Good. So now let's run the data head again. Sales.head. Give us just three. Okay. Now we have revenue column added here. Good. So how do you add a new column? This is the name of the data set, which is sales that we imported. This is the data frame that we imported, sales. Then revenue is inside data frame called sales. Now equal to quantity times unit price. So anytime you want to write the name of a column in a data frame, you must attach the name of the data frame before you write the name of the column. That's how to call a column name in Python. Then the next one is what? We want to create total cost. So equal to total cost is quantity by unit cost. So this is the easiest way to write Python code. Instead of writing it long, first of all, you write this, then assign the name last. So because quantity times unit price is what we are looking for. So I will bring out the column again. That's quantity. So because this is correct, so I'll just copy this again. Quantity by unit cost. So I'll go back again and pick unit cost. Remove the white space and close it. So if I run it, I've calculated it, but I've not assigned it to, I've not inserted it to the data frame. So now I'll do that. So the name is supposed to be total cost. So now we have total cost equal to this. If I go back and run my sales.head. So let's check. So we've added the total cost. We want to create another feature called profit. So this is sales, and profit is revenue by total. So we've created revenue. So we created a column called revenue, and this is revenue. So I will just copy the revenue. Revenue by total cost. So I still have my total cost. I'll take it and paste. Good. So I'm going to run this. So because this is the name I want to give the column. So sales profit equal to, is square brackets and not curly bracket. Good. So I've created profit for profit. Now the next one is what? Profit margin. And profit margin is profit divided by revenue. This is revenue times 100. That's how to get your profit margin. So I'm going to sales, this is profit. That's the name of the column, profit divided by revenue. So this is profit margin. So for this, I'm going to calculate it first before attaching it to the data frame. Then times 100. So this is our profit margin. So let me check profit margin. So this is the profit margin. Now let me attach it to the data set so that it will be part of the data frame. Now let's go back and check. Run this. So now we have our profit margin. We have profit and we have profit margin. The next one is we want to extract month. So we want to extract a column called month. So we're going to extract it from order date. So let's go back and run our sales head. Good. So we have the month, but this month is written in numbers. For example, this is January, February. Okay, because we don't want it in number format, we want it in name formats. Like January, it will be written as, it will be spelled as January. So we want, I'll come back here and add underscore name, then come back and run it. So we now have June, January, February instead of 6, 1 and 2. Then okay, so that's what we just did here. That's month name. Then another feature is quarter. We want to get quarter from other dates. So we want to get quarter. So let me change this to other month instead of just month. Other month. So I'll come back and check if it has reflected. So we have other month. Good. So now I'm going to extract another feature. So we're going to generate another feature called quarter. So we are going to name the column quarter equal to sales. So since we are generating, extracting since we're extracting the name from other dates, we're extracting the quarter from other dates. So I will just copy this here and use dt dot quarter. I will run. So let's go back and check it. Okay, so we have quarter, first quarter, second quarter, and the rest of them. All right, so the next one is what we're going to extract year from the month again. So I have the column year equal to, so still from other dates. So I will just copy it. So I'm going to use dt dot year and run it. So let me go back again and check the head and see. Good. So now we have the year. Then the next one is what? Day name. So sales year. Okay, no, so sales day, sorry, day. Sales day equal to, so still from other dates. I will copy it again and add dt dot day. So because I want the name, I'll just add the name and run it. So let me go back again. So let's check. So from here we have extracted Sunday, Friday, Saturday. So we've actually extracted the names from these dates. Okay, so this is still feature engineering. We are still generating features that we will use later from this data frame. So if you look at this, we started generating from here, from profits. So from revenue, total cost, and the rest of them. Yes, we started generating from revenue, then total costs, profits, and profits margin, and that's what we have there. We want to create another feature called weekend. We want to create want to create another feature called weekend. So NumPy is going to do this for us. So we use so anywhere sales order ID. So anywhere order ID, this column order ID, day of week is greater or equal to 5. You give us weekend. Every other thing, give us weekdays or weekday. So this is just trying to tell us that we want to create a column called weekend. So we use numpy.where for the function. So anywhere you see other dates, anywhere that the date other date is above 5 or from 5, give us weekend. But anything that is not above 5, give us weekday. So this is just trying to tell us that Monday is 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5. So from Friday, give us weekend. Anything below Friday is weekday. So I'm going to run it. If we go back to our sales, we run it. So we have weekday. Okay. So we have weekend, weekday, weekend. So that's how to extract another feature called weekend. Now let's look at data transformation. What is data transformation? Data transformation is the process of changing the format, structure, or value of existing data so that it is easier to analyze or use. And I said that I'm going to tell you the difference between feature engineering and data structure, and also data cleaning. Okay, so we're going to see the difference between data cleaning, feature engineering, and data transformation. Data, trans- data transformation is when I transformed order ID from from object to date type, from the data type object to date time. That's data transformation. Now, feature engineering is extracting extra columns. When you're trying to extract extra columns from the original data frame that you have, that's feature engineering. While data cleaning is you're trying to fix bad data. For example, when we removed duplicates, when we dropped all the rows with empty rows, that's data cleaning. Where we have empty records, sorry, and we drop them. Also, if you're trying to normalize your data, like make every first letter to be capital letter and all that, so that's data cleaning. So there is actually a difference between data cleaning, feature engineering, and data transformation. Sometimes people mistake data cleaning and data transformation, or feature engineering and data transformation. They are not the same. All right, so let's go back and look at filtering, how to filter in Python. So let's look at data filtering in Python. So in data filtering, what it means that anytime you hear data filtering, you're just trying to display data that matches one or more specified criteria. So for example, if the criteria is Lagos, you want to filter orders or sales from Lagos, it means that you just want to display all the information about Lagos. So let's go back to the data set now and check. So if you look at these data sets, under city, we have Abuja, Lagos, and we have other cities. But what we want to see is only Lagos records. Now, we don't want to see any other that is not Lagos. We only want to filter Lagos so that instead of city giving us Abuja, Lagos, and Abuja, we will only see everything about Lagos. We won't see any other thing that is not Lagos under city. So that's just what filtering is all about. So now we go back and bring out the column, which is city. Okay. So where city is Lagos. So if I run this, it will give us in Boolean form, but I want to display it. I want to display it. So we have, where's the city? Okay, so we have every record, Lagos record under city. So now I will just come here and give it the name Lagos orders equal to, good. So that anytime you want to make use of this information, you can just run the name Lagos orders. So this information is now stored as Lagos orders. Then the next task is filter orders from Abuja, the same format, where city is equal to Abuja. So this is just display it. Okay, so you just display. Now this is what, let me store it as Abuja sales. Good. So now I've stored it as Abuja sales. So anytime we want to make use of this filtered information, we can just run Abuja sales and we have the record. Then the next one is under category, where electronics is category, where category is electronics. So all right, so the column name is category. So I'll just copy this category. That's the name of the column. So where category is electronics, filter it. So remember, always put it in a quote. Okay, so we want to filter it. Good. Okay, now let's save it as electronics. Good. So anytime we want to make use of this only electronics, you can run it. Then the next one is we want to filter where revenue is greater than 500,000. So we want to filter where revenue is greater than 500,000, meaning every information that is above, where revenue is above 500,000. So we are going to filter it. So this is our revenue. So this is our revenue. So the column is revenue. So we want to check where revenue is greater than 500,000. So, all right, for the sake of display, I'll display this. So all these things are above 500,000. So you can't get any record that is below 500,000 here. All right, so I will save it as above revenue. Okay, let me use high revenue. High revenue equal to, good. So I've saved it. So I've saved this. So remember, this is different from add calculated columns. Hope you know. So we are not adding this to the column, to the data frame. We are just filtering, displaying. So this is different from when you are trying to do feature engineering. So this is different. Now, the next thing we are going to filter is profits less than 550,000. So let's go back and check profits. Okay, so we want to filter all the records that the profit is less than. So call the name of the column we're looking at, which is profits. So profits less than 50,000. Okay. So we don't want it in Boolean form. We want to display it. I'll add the name of the data set, the name of the data frame, and good. So we have only this. So this is minus and this is 0. So this is the only place that we have. So this is the only place that we have okay. So this is the only place that we have profits less than minus 20, meaning that all the profits that we have here is more than 50,000. All right, that's good. Then the next filter is weekend orders. So we want to filter weekend orders. So remember, we generated weekend column when we were trying to during feature engineering. So we generated weekend column. Now we want to filter only orders during weekend. So this is weekend. Is weekend. Okay. So this is weekend orders. So if you look at the day, we have Saturday, Sunday, Saturday, Sunday. Good. All right, so this is how to filter only weekend orders. Now I will save it as weekend orders. So once you save your data, if you save any record, new record, it won't display until you run what you save it with. For example, if I run this, so it will not display. I will come back and copy this. Is either I place enter and paste it here and run it again, or I'll go to a new cell and run it so that it will display. Now the next one is filter delivered orders. So for the delivered orders, we check the okay. So let me check the columns again. Sales.columns. Okay, so we have data analyst columns. So we want to filter delivered orders. So we can get that from order status. So the name of the column is order status. So if you look at this, you can't see all the columns because of this. So this is trying to tell you that we still have other columns here. So we still have other columns, we still have other columns, we have other rows. So it didn't display everything. Now for the delivered orders, so we are making use of order status. So where order status is delivered. So we want to filter where order status is delivered. So let's display it now. Okay, so we have incomplete inputs. Sorry, I'm going to remove this. So I'm going to save this as delivered orders. Delivered orders. So there is no white space when you're naming a data frame or if you're creating a variable. So you remove white space. That's why I'm using underscore. We want to filter return orders. So we're looking at column called return. Okay. So we want to check. So under return, we have yes or no. But we want to display all the records where returned order is yes. Good. Because I want to display all the columns. So naturally, by default, Pandas will just display the first 5 and the last 5, or it will just display, it won't display everything, both columns and rows, especially when you have plenty columns. So, but I want to see everything. I will just run this code here before I continue. Let's set options. Yes, I want it to display dot max value. Then I will set it to none. Display dot max underscore columns colon. Then I'm going to set it to none. Okay. So pd dot set underscore option display maximum volume columns. All right. So I'll run it. Come back and rerun this. So if I run it, it will display all the columns, all the data sets, so you see everything. So now for the return, equal to yes. So let's go to return column, which is yes. So we have only yes record. So these are all the record, all the orders that was returned. Then for the order status equal to delivered. So I'm going to run it too. So I'll go straight to order status. So we have, since we filtered delivered, so we have only delivered record. So that's all about filtering. Then the next thing we'll be talking about is data sorting in Python, how to sort data in, whether in ascending order or descending order using Python. We're going to talk about data sorting in Python. Now, data sorting in Python means you're trying to arrange your data in a particular order, either in ascending order or descending order, just trying to arrange a filtered, or maybe trying to sort your data in a particular order. That's just what data sorting is. So in Python, you can sort in ascending order, you can sort in descending order. So now we want to give an example using revenue. Now this is our revenue. So we want to sort revenue in ascending order, to appear in ascending order. This is revenue. So by default, if you sort in Python, it will be in ascending order. So now I'm going to sales.sort value. So we want to sort revenue in ascending order. So I'll run. So if I run this, it will sort in ascending order from minus 0.88, so till the final one, final revenue that we have. So this is how to sort your column, how to sort your data in ascending order. Now we want to sort revenue again in descending order. So I'll sort dot sort value. So we use sort values. So we're sorting revenue again. Now I'm going to give it this argument, ascending equal to false. We don't want it to appear in ascending order. That's just it. So I will run it. Okay. So I have attribute error. Data frame object has no attribute. Sort values. Okay, this is wrong. Sort values. Good. So now let's go back to revenue. So this is revenue. Now in descending order, this is the highest down to the lowest. All right, so we're going to sort by quantity. Sort values again. So this time around, I will just sort by in ascending order. So no need of good. So if we go to quantity, so this is quantity in ascending order. So if we sort in descending order, it will start from 4 to 1. All right, so now let's get the top 10 highest revenue. We use n largest, sort.n largest. Now we are looking at top 10 and we are sorting revenue. Good. So I will run it. Okay. Sort. Sorry. So this is sales. That's the name of a sales.n largest, not sort. That's the name of a we are trying to sort sales and not sort. Sorry. So this is sales.n largest and not sort.n largest. So we are sorting sales. Under sales, we are sorting revenue. So I'm going to run it. Good. So let's go back and check. Okay, so this is the top 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the same way you can also sort the bottom or the lowest 10. So let's lowest 10 revenue. So the sales dot n smallest. So we're looking at 10 and revenue. All right, so this is sales dot okay. So I'm going to run it. Now we have the lowest 10. Let's go to revenue. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So even if you want to sort the top or bottom 5, you can still, or lowest 5, you can change it to lowest 5 by revenue. So okay, this is largest 5 by revenue. We have this. So if you want to change it to sort by bottom 10 or lowest 10, you can change it. So that's how to sort. Then let's talk about aggregation. Aggregation is just like you're trying to summarize summary statistics, kind of. So for example, we want to check the total revenue. So sales. So under total revenue, the revenue that we created. Okay. Okay, so we want to check the total revenue. Where is the revenue again? So So for total revenue, we use dot sum. So this is the total revenue. Everything under the row revenue, under column revenue, sorry. So it will just calculate everything under this revenue. That's what we have here. So the next one is average revenue. I will just copy this, paste it, and change this to average is mean. So since average is mean, I'm going to change it to mean and run it. So this is the average revenue. Then the next one is median revenue. So we want to check the revenue at the middle. I'm going to change this to median. Good. Then the next one is mode. The same. I will change this to mode and run it. So we have this. Let me add dot sum. So we have the mode. Okay. Then the next one is what's maximum revenue. So that's dot max. That's how to check the maximum, the highest revenue. Then the standard deviation, that is STD. So it is good for you to know all these functions and how to use them. The next one is what's the variance. Then for minimum revenue, you change this to mean. So this is the smallest revenue minus. For the total orders, I'm going to check our columns again because we have so many. We have so many. Okay, we have other maths, other status. All right, so that's order ID. Now for total orders, we have order ID dot count. So we have 990 orders. Then we have for customers, total customers, we use n unique dot n unique, not unique, not m, n unique, n unique. Good. So this is the function that we use. Okay. So for total customer, bring out the column, which is customer ID. So dot n unique. So we still have 919 customers. Then for total products sold, that's quantity. Quantity. Dot counts. So we want to count. Okay. Syntax. All right. So this is not a curly bracket. Good. So we have 990. Good. Now the next thing we'll look at is group by analysis in Python. Group by. In fact, group by is one of the most important analysis in Python because in Python data analysis, because every project in Python data analysis requires group by analysis. You must in fact, you must use group by. Group by, we group, for example, we want to group revenue by region. So it will group revenue, it will bring out all the region. If we have only 3 regions, so it will just bring out the 3 regions and calculate revenue inside. It will calculate the revenue for each region. Instead of, let's say that we have 3 regions, but it was just the 3 regions that made up the 990 columns. Group by, we just aggregate the, let's say the region is east, west, north. It will just aggregate all the values, all the revenue in east, revenue in the west, revenue in the north. So that's just how group by works. For example, under region, let me run the head, our data, sales. So let's see what we have. Okay, under region, we have central north, central south. So for group by, we'll bring out all the values under central, sum it up. So that central we now have calculate everything into sum of the total. If it is sum, it is sum of the total for central. Then it will pick out sum of the total for south, pick any other region that we have. So let's check the number of regions that we have. So this is a region. This is region dot unique. Okay, good. So we have central, south, north, west, east. So it will sum up all the values for all the revenues for central, revenues for revenue for south, revenue for north, revenue for west, and revenue for east. So this is just how group by works. So we're going to, let's see this. So sales dot group by. So revenue by region. So this is region. So we want to group it by region, then bring out the values or the revenue values and sum it up. So this is group by central. This is central. For the east, this is it. So this is how to use group by. Let's check the next one, which is average revenue by region. So the same method, we're going to use group by. We're looking at region, okay. So now we want to group it by region. Then go to revenue column and use revenue to do the calculation. Then for average, average is mean. So bring out the mean of revenue for all the groups. So group by region means group it into central, east, west, north, and south. Then average means average revenue for central, bring it out. Average revenue for east, bring it out. Good. So this is average revenue by region using group by. Then the next one is revenue by category. Revenue by category. So let's go back. Okay. So we have our category. Okay. So I'm just going to copy the revenue. And so for each category, under beauty, we have this revenue. Under electronics, we have this revenue. So for all the category, it will group it and bring out the revenue for them. Then the next one is revenue generated by each salesperson. So sales.group by again. So for this, group it by salesperson. Then calculate revenue. Use revenue for each column. Then you're going to sum it. Good. Then Aisha, Chinedu, Daniel. So this is revenue generated by each person. We have order by payment method. So this is how to check the common payment method that they use. So sales.group by. Okay. And paste it. Good. So we want it order by payment method. Good. So I'm going to use order ID, order date. Okay. So we use order ID and count it. Okay. Dot count. Good. So bank transfer 226. So I think the most common is cash. That's the highest. Okay, no, that's mobile money 269. Mobile money is 269. So this is the highest, the most common. Then we have revenue by month. Revenue by month. So we want to group month from January to the last, if it is December. And we want to calculate the revenue for each of the months that we grouped. So sum it. I'll run it. Okay, so we have error, key error. So what's our error saying? Month. All right, so let me go back and check the spelling of a month. Okay, so we don't have, okay, we have order month and not month. So I'm just going to copy this order month, replace it. So this is revenue by order month and not just month. So we have, it here. Okay, so the next one is revenue by city. So meaning we are grouping by city. Group by sales dot group by, okay, city. Then sum the revenue for each of the city. Then and sum it up. Good. So Lagos, from Lagos to Port Harcourt, this is different revenue that we generated from each of these. Okay. All right. So now the next thing we will be talking about is pivot table in Pandas. It's not just in Excel that you use pivot table. We also use pivot table in Python. And what is pivot table? Pivot table will help you to summarize your data, to summarize and analyze your data. That's the work of pivot table. That's what you use pivot table for. Okay, so I'm going to teach you how to use pivot table in Python. So, for example, pivot table in Pandas is used to summarize and reorganize data, so you can quickly compare values across different categories. Okay, now we want to create a pivot table for revenue and region. So Pandas is going to do the work. Pandas dot pivot table. So this is the function pandas dot pivot table. Now we want to create it from sales data frame and values. So we want to give it values from region. So we want to bring region under values, then index. Index is just like row. Index is sorry, revenue under value, not region. Then index under region under index, region under index. Then the aggregate function that we're going to give it is equal to sum. So we want to give it sum. Good. Now pivot table from sales data frame value. The value is numbers. So we bring revenue to number. Then index, we want to index it the way we group by. So we want to use region to index it. So index will be the row, the starting row. That region aggregate function is sum. Good. Now I will run it. Okay. So we have type error, keyword value. Okay, no, not value, please. That's values. Okay. So now this is our pivot table. This is region and this is revenue. This is region and this is revenue. Now we have all the values for region and we have all the values for revenue. And also you can equally visualize this. In fact, this is the easiest way you can visualize two different columns. So we have, by creating a pivot table, you just use it to summarize the data. Then you've analyzed this. For us to visualize this, I will come here and give it a name. So this is revenue by region. So I'm just going to assign the name revenue by region, but because of white space, I will use underscore. So I'm going to run this. All right, so this is what we have here. So if I want to plot this using just Python, or using Pandas, sorry, not Matplotlib, I just want to quickly visualize this. I'll use dot plots. So I want to use bar charts. So I'll run this. All right, so I want to remove this X label. So if you want to remove X label or whatever region, so I'll add semicolon and run. So we have this visualize. Okay, so this is how to create your pivot table. So once you create a pivot table, it must be in this. So it must be arranged in this format. So I can quickly do this. So now I want to change this color. I can just use color equal to, I want to change it to red. So I have this color. Okay, so this is how to use pivot table in Pandas. You can use it to organize and arrange or summarize different columns in your data frame. Now let's look at statistical analysis in sales. We have descriptive statistics. Descriptive statistics is it helps to check count, mean, median, mode, minimum value, maximum value, range, variance, standard deviation, quartile, percentile. An example is when you're looking at average order, average sales, average quantity, total, medium, middle, and the rest of them. So you want to count. So that is just descriptive statistics. Then the next one is distribution analysis. Distribution analysis in statistical analysis helps us to understand how the data is distributed. For example, revenue normally is revenue normally distributed also when you're trying to check outliers. Okay, so we're going to look at them. The next one is frequency analysis. So this is when you want to count occurrence, and it is most when you use it when you are looking at the most common payments, the same way we did when we looked at the most common payment, and I think it was mobile transfer. Then the next one is correlation analysis. Correlation analysis measures relationships between numerical variables. For example, you want to check, does higher quantity increase revenue? So correlation analysis will help you to check if there is any relationship between two different numerical columns. For example, you want to check if this column is increasing because of an increase in another column, or does anything that happened in this column affect another column. So that's just um, correlation analysis. You're just trying to check relationships. Then the next one is outlier detection. It detects unusual record. What's an outlier? An outlier is just an unusual record. For example, if you've been recording a certain amount in from January to August, then around August, that's you found out that there is this amount that is unusually high or unusually low. That's an outlier. Okay, so outlier is just an unusual data that is different from others, so you can do that. So you use outlier to statistical analysis to detect it. Example is which sales are unusually high, which other are unusually low. So that's just outlier. Then the next one is skewness. Skewness measures the asymmetry of a distribution. For example, is the data evenly distributed around the average, or is it pulled more to one side? So that's just skewness. And skewness is, you can in skewness it can be positively skewed or negatively skewed or evenly distributed. So when it is one-sided, it is either left, it is negatively skewed. When it is the other side, it is positively skewed. And when it is normal, evenly distributed, it is evenly distributed. Okay, so that's just what skewness is. Then the next one is what kurtosis or kurtosis, depending on how you pronounce it. Kurtosis measures how heavy the tail of a distribution are. So it tells you whether there are unusual many extreme values or outliers. It answers the question, does the data set contain more fewer extreme values than a typical distribution? Okay, so that's just what kurtosis is. Okay, right. So hypothesis testing. Hypothesis testing helps us to check whether something that happened is real or it just happened randomly. So that's just what hypothesis testing means. It helps to check whether something that happened whether something that happened is real or it just happened randomly. Okay. So we have a independent t-test. It compares average revenue between two regions. For example, is the average revenue in the north significantly different from the south? The next one is one-way ANOVA. One-way ANOVA is another hypothesis testing that compare average revenue across all regions. For example, do regions differ significantly in average revenue? So that's that with one-way ANOVA. Then another one is chi-square test. Chi-square test is another test that checks relationships between, for example, payment method and other status. Let's use this as an example. Is payment method are associated with other status? Like, is payment method associated with other status? So that's what chi-square test is all about. Now let's quickly go to exploratory data analysis. Exploratory data analysis is another important analysis in data analysis. Okay, so now it helps you to understand data and discover the story hidden inside it. Exploratory data analysis will help you to answer the questions that you have in your data set. Okay, it will help you to answer hidden questions, to uncover hidden things that you have in your data set. Now let's look at the questions that we have. So to help us to answer business questions like sales performance, product analysis, customer analysis, region analysis, salesperson analysis. These are what exploratory data analysis can help us to do. Okay, so we're going to answer these questions. And this is, remember, when we were talking about group by, I said that group by is one of the important analysis that we do in data analysis. Okay, so group by analysis is one of the most important. It is one of the most frequently used. In fact, it is one of the most frequently used in data analysis projects. Okay, so for this sales performance analysis, we will still be using group by. Okay, so the first one is, what is the total revenue? So we want to check the total revenue. So some of these things we've answered them before, but it's just that we did not explain that we were doing exploratory data analysis. Okay, so from sales data frame, so sales.group by, okay, sales.group by. So we want to group by, okay, so all right, so this is what is the total revenue. Sorry, so we're not grouping anything. So total revenue from sales. So we're looking at the column sales. We're looking at the column revenue from sales. Okay, so remember the revenue, this is case sensitive, so we are going to, good, so from here, revenue dot sum. So this is the total revenue. Okay, good. The next one is what is the total profit? The same pattern. Which month generated the highest sales? Which quarter performed best? So which month generated the highest sales? I'm going to, so we have sales dot group by. So we want to group by month, and remember we used other months. So we've actually answered this before. So we group by other months, then that's which month generated the highest sales. So let's go back to the data frame that we have. Okay, generated the highest sales. We can't see sales, we're going to use okay, so we're going to use revenue again. Okay, so we're going to use revenue, total cost revenue or profit. All right, so we're going to use revenue. So good. So you group by then sum it. So this is aggregation. So we are going to sum it. Okay, so with this. Now, if you want to check if you want to see it, you want to visualize it, I'll just use, what's the name again? Total highest revenue. Okay, I'll just use month revenue equal to, so I've assigned a name to it. Good. So now I can plot it. And remember, for this, we're going to use line chart. So in Pandas, you just dot plot. So default in Pandas is line chart. So if I do this, it will give us the chart. Okay. So from here we're looking at December. Where's December? Okay, this is December, February. Okay, it's around December, February. Okay. Okay. So from here we have this is not it's not well arranged. So I can also check it very well. But for line for trends we use line chart. But for me to see what's going on very well, since I will just use, since the chart is small, I'll just use kind equal to bar. So let me just give it. So let's see. So from here, we're still having December. Where is December? Okay, this is it. Okay, all right. So this is it. Okay. So this is the value for December. Okay. So it's still the same. So if I remove this to take it back to line chart, because in Pandas the default, without adding anything, default is line. So I'm just going to leave it as line chart. So this is it. Now the next question is what? The next question is which quarter performed best? So for that, still going to use sales dot group by. So we want to group quarter by revenue. So for this will be that's sales performance. So we're looking at revenue. Good. We'll be using revenue. Okay, so which quarter? I'm going to copy this. So this is capital letter. So that's calculate using revenue. Revenue. Then you sum it. Good. Then for the quarter sales, because I want to plot the chart, I'll assign a name. So now dot plot. Okay, so we have first quarter, second quarter, third quarter. So this is, we have the first quarter, the second. All right, so I'm just going to use bar again. Good. So from this, the highest is the fourth quarter. All right, so that takes us to the second analysis, which is what product analysis. Which product sells most? So it's almost the same thing. Which product sells most? So this is dot sum, the same thing we did here. You just bring out product name dot sum. Okay, you bring out the column, product name, then dot sum. All right, so let me just quickly do one. Which product have the highest profit margin? It's still the same for these two category generated demand. So these two, we are still using the same group by, and this, so we are only repeating what we did, what we've done. That's what we are doing. So which product sells the high? So I'll just bring out the product name. So let me just compare and copy. So I'll just copy this. So this is the, and submit. Whoa. Okay, so I'm going to, since it is product name, I'm just going to count it. Dot count. Yeah. So it will bring all the products. Okay. So this is product name is not an integer. So you can't sum it. That's why we have that that's output. So product name is not an integer, it is an object. So you we count the number of rows or the number of objects in a row. Okay. All right. So now let me just remove it. All right. So for the customer analysis, who are the top 10 customers? Okay. Which gender spends more? Which age group spends the most? Now, for the age group, when we were creating during the feature engineering, we did not create age group. Okay, we did not generate age group. So once you have age group, you will still use group by. Okay, it's still the same pattern. But who are the most top 10? All right, so let's answer one or two from customer analysis. So we want to get um, the top 10. Okay. So who are the top 10 customers? Okay. So sales. All right. So before I do this, let me quickly get the dot columns. Let me quickly get the number of the columns. Okay. So from here we have customer name. Who are the most? All right. So I'm going to use customer ID. So group by. Who are the most 10? Okay. So group by okay. So if you look at this, I'm going to use customer name because not customer ID because we want their names. So just group by this. Then revenue, either revenue or profits. I can use any of them. Okay, now I'll use revenue. Dot sum. Good. Now I want to sort values in descending order. Ascending equal to no, not true. Ascending if equal to false. Good. Now I want the head, the 10. Okay. So let me check. Okay, I will run it. All right. So now we have head is not defined. All right. So this is dot head. Good. So we have the top 10 from Musa to Mary Lawal. All right, so this is the top 10 customers. This is just trying to tell us that we grouped customer name by revenue. We wanted to sort it in descending order. That was the reason why we put ascending equal to first. Then for the head, the 10, the first 10. So this is, instead of giving us everything under name, we use head 10. So we use it to bring out this, okay? So the same way, if you have your data sets, data frame, use dot head, the number to get the number. Now I will come here and use the name, top 10 equal to, then remove the white space because this is a name. I'm going to remove this white space. Good. So I have this now. The same way, if I want to quickly visualize it, I will use Pandas. Then I'm going to use bar. Okay, then I will plot. Now from here we have the highest person is Musa. That's the highest from the top 10. So this is way too high from others. Okay, good. So now we have which gender spends more. Good. Now let's even check the gender that spends more from this. So I'm going to okay, dot group by again. Gender. So I want to group, where's, let me check the, okay, so this is gender. I'm gonna copy it, paste. Okay, so by revenue again. So revenue. Dot sum. So female 6.9 and male 7.5. So it's obvious is male. So let's quickly go to the next. We have regional analysis. Which region generates the highest revenue? I think, yeah, we've done this. Which city has the most orders? We've done something like this before. Which region has the highest profit? So we've done this before. So you can go back and check where we answered the question. For the salesperson analysis, which salesperson generated the highest order? Okay, who sold the most units and who achieved the highest average order value? So we will be answering some questions, but all these things are just group by. Okay, it's still group by. Which salesperson generated the highest sales? So you group sales, sales with salesperson, then times use revenue to for the values. Okay, then who sold the most units? Do we have units? Okay, so who sold the most units is just, we can use order ID to count. Yeah, we can use order ID. So then let's quickly go to which shipping method is most used. Okay, so we have shipping method. So I can quickly answer this. So I will come here. So most of these ones that I skipped, all of them are grouped by the same thing we've been repeating. So which shipping method? Sales dot group by. So no need of repeating the same thing. So let me group by shipping method. Okay. Then then I can use okay. I can use order ID and count. This is shipping method. Shipping method. Good. Now let's quickly go to KPI dashboard. Okay, so we want to go into this KPI dashboard. So for this KPI dashboard, most of this, we've been using Pandas to plot our charts. Now I want us to also add Matplotlib, because we imported the library. Matplotlib is a library that is specially meant for visualization. We also have Plotly, okay, for interactive dashboard. So plotting your visuals, you can use Matplotlib. You can also use Plotly, sorry, depending on how you want it to appear. Okay, now let's quickly go into KPI dashboard. correlation analysis using heat map. Now I selected some columns that we'll be checking. So we're going to use these columns for the correlation analysis, okay? So instead of using all the columns, remember we have plenty columns, they are too much. So we just I extracted the relevant ones for the analysis. That's revenue, profit, quantity, customer rating, delivery days, and age. So now for the correlation analysis, that's correlation. Correlation equal to, so from sales, okay, so I will get the all these columns because this is the column we'll be using. So I will just copy it and paste. Good. So dot cor. Okay, good. Now for the fixed size, I want to give the fixed size 8 by 6. So I'll just plt dot figure plt dot figure. So fixed size equal to. So I want to give it as a, okay, let's use 8 by 6. Good. Then I'll close the other bracket. Okay. So all right, so dot heat map, because we imported Seaborn as SNS. So SNS dot heat map, that's correlation, this correlation, correlation. Then annotate equal to true. So I just want the values to appear inside those small boxes. So I'll just use a note equal to true. Then cmap equal to. So we have different colors in correlation, but for this one I'm going to use cool warm for heat map. Sorry. So I'm going to use cool warm. Cool warm is from blue to red. I think from blue to red or from red to blue. So that's from blue to red, from red to blue. That's cool warm. So then for the format, I want the numbers to appear in 2 decimal places. So I'm going to use 2 decimal places because for the format is 2. Okay, that's a then okay, good. Now, so I have this bracket. All right, so I've closed my bracket. Now for the title, I want to give it a title, and I'll use Matplotlib, that's plt dot title, plt dot title, brackets. Title is just so that's just correlation heat map. That's the name of the heat map. So I will just use correlation heat map. So in quotes, correlation heat map. So I'll just close it. So before I show it, let me run it. Okay. So we have this. So I can just add okay. So plt.show dot show. Good. So we have correlation analysis. So this is the correlation heat map that we just created here. All right. All right, so this is it for data analysis project using Python.